Hey everyone, I want to take a look at number 4 on my practice homework for the definition of the derivative homework. In this one, we're given a graph of a function g, it's shown below, and we're going to estimate the following derivatives. So a ruler or straight edge may be help here. So remember, the derivative is nothing more than the slope of the tangent line, or we say the slope of the graph at that point. So what would g prime of -2 be? Well, when x is -2, the value of the function g is about negative 0.4, 0.5, somewhere in there. But that's not what we're looking for, not the value of the function. We're not finding g of -2, it's g prime. So that's the slope of the tangent line. So what I want to do is I want to take my ruler, and what would that tangent line look like? It would be the line that just touches the graph of the function locally right at that point. We've talked about that, right? So there's the bottom of this ruler would be approximately that tangent line. And so I can draw that line in. And then we can then estimate the slope of this line. Okay. Again, in estimating this line, the way you draw it, I could have a little wiggle room. I could have, drawn a little steeper, maybe a little less steep. So there's going to be some variation in the answer that you get. So you might not get exactly what I have for the answer for this, but let's see, in going from one point here to another point, maybe up here, what is I chose that point there because the horizontal change going from my point to this point on this line is 1, right? I go to the right 1, and then I go up. Now this is about, it's not quite -0.5, maybe -0.4. So if I'm moving up to this point, I'm going to go up 0.4 and then 1.4, 2.4. So what I'm saying for the slope of this line, I'm estimating it to be about a vertical change, right? A rise of 2.4, right? Go up 2.4 and then over 1. That's the slope, which is of course 2.4. Okay, so that's just picking 2 points. You can pick any 2 points and you can estimate, and you might estimate the slope to be 2.3 or 2.5. There could be some wiggle room there. Okay, so that's what I'm going to say. The slope is approximately, so I'll do little squiggly lines, approximately 2.4. Okay, what's the slope at -1? Well, at -1, it looks like the graph of the function has a local maximum. Right, there's the point right there at the top. The value is about 0.7, 0.75, whatever, something like that. But again, what's the tangent line? Well, since we're right at the top, what's the tangent line going to look like? It's going to be a horizontal line. I'm not going to draw that line, but if I drew that line, it would be pretty close to being horizontal. Again, there's some wiggle room, so you might have a slight negative slope or positive slope. But I'm going to draw it just so it's horizontal. So if it is horizontal, what's the slope of any horizontal line? Slope of any horizontal line is 0, right? And so it's going to be close to 0. I mean, you might say it's a, 0.05 or, something real small positive or something real small negative, but more than likely, I think 0 is a good estimate for that. Okay. What's the derivative at 0? What's g prime of 0? What 0? The value of the function is 0. We're right there. And now we're going to draw the tangent line. So here, it's actually going to pass through the graph there, because the graph is decreasing sort of at an increasing rate, and then it's decreasing at a decreasing rate. So it's going down always, but there's some curvature, and we'll talk later about curvature of the graph or the concavity of the graph. But it looks like, right at that point, the slope is roughly like this. I'm going to just draw that line right there. Okay, approximately. And, again, some wiggle room, but it looks like about, roughly going over 1, down 1 each time, over 1, down 1, over 1, down 1. And maybe it's, over 1, down 1.2 or something. I'm going to say it's close to -1, right? So the slope of this line is close to, down 1, over 1. So about -1. Now you might say it goes down a little further, maybe -1.1. -1.2, -0.9, something like that. It's close, but that's going to be about -1. Okay, and then the other ones will be done similar. Let's look at number 4, and I've got the answers to this on there. Or number 4, part G prime of 4. So G prime of 4, we're looking at It's right about there on the graph, about, G of 4 is about 3. But the slope now, what's the slope of that tangent line going to be? If I draw it so it just touches that graph, maybe something like that, right? Just touching the graph. I didn't do a very good job of that. Sorry. Let me redraw that. Okay, little wiggle room. Okay, and you might draw it even a little steeper than I have. But again, it looks like to me, here's a point right here. It looks like going from this point to our point, I go over 1, horizontally positive 1, and then vertically I go up 1, 2, 3, 4, 5. So maybe I'm saying the slope is about positive 5. I think I've drawn this line maybe not so good, but I actually have positive 6 as my answer. So if I were to draw it just a little steeper, though, you can see it's just a little bit of a change, and you can see that I get, positive 6 now, because I'm going from this point here to that point. So now I'm going over 1 and up 1, 2, 3. So I mean, if you get an answer in this one between 5, 6, 7, somewhere in there, that could be reasonable. And that's going to happen the steeper the line is, because if you get steep, right? This line right here, if I were to draw it, maybe I go over 1 and up, I don't know, way up there. Maybe I go over up 20, so slope is 20. If I just do a little slight change like that, it might be up 25 now, right? I mean, so steep lines will have more uncertainty. The ones like that are close to here where the derivative is 0, little movement there doesn't make a great change in the slope. So just keep that in mind. And we're looking for approximations here. Okay, so I hope this is helpful on this one for you.